sessions. Actually, a few hours later. It's not immediately ready. All right. So this is the page we want to look at?
Yes.
Okay. It's going to make me look bad. You're starting a tutoring service and you decide to charge $11 per tutoring session. Must be a third grade tutor. Write a linear model to relate your income Y to the number of tutoring sessions. So what would Y be equal to in terms of X? What'd you think? What if you do 2 hours? How much you gonna make?
Oh, $22.
What if you do 3 hours?
$33.
So what are you doing? You're multiplying what by what?
11 by 1.
11 by the number of hours you work, right?
Yeah.
So
yeah.
It's 11x, where Y is my income, and X is the number of hours, or the number of sessions I give. Okay? Now, if we want to graph that, that's pretty easy to graph. Where's the y-intercept?
0 or 1.
Oh, you got it right. 0. In other words,
0. Okay.
Remember what the general formula is. Y equal mx plus b, where b is the y-intercept. And in this particular case, b is 0. There's no number after the 11x. Okay.
Right. Okay.
So my y-intercept is 0 and my slope is 11. Well, that's kind of what it looks like. Okay. So that would be y equal 11x. And that's a graph of it. And then they ask you, what's the y-intercept? Well, we already answered that. What does it mean in the context of this situation? It means if you do 0 tutoring sessions, how much do you make?
Nothing.
That's what it means. In other words, the y-intercept is what you make. It's what y equal to when x equals 0.
Okay.
Okay, that's what y-intercept always means. It's just that sometimes it doesn't go through the origin. It'll go through a point up here, and maybe you have a function where even if you do 0 sessions, you'll make $5. So the y-intercept would go through 5. Okay. How many tutoring sessions did you complete if you made $198? How am I going to solve that? Here's our function. They want to know what x would be if y is $198.
Right.
So I'm going to plug in 198 for y, and I'm going to solve for x. You have a calculator in front of you?
I have my phone, which has a calculator on it.
You should always have a calculator, Demetrius, whenever we're having a session, because you almost always have to do lots of calculations.
Okay.
This being one of them. You can use your phone that's fine. I would prefer you to use the calculator you're going to use in class. What calculator do they insist you have at Pomona? Are they insisting on the TI Inspire yet, or are they still letting you use TI 84 or 89?
I don't know. So my teachers just said to get either a Texas Instrument or Casio.
You're a sophomore?
Yeah.
At Chatfield High School, they're requiring every single high school student to have the Inspire. The Inspire is the state-of-the-art calculator now. So it's just a matter of time probably before your school insists upon you having an Nspire. Right now they're saying you can get by with any old graphing calculator. That's fine, but I'm just telling you that if you got to go out and buy one, buy the Nspire. They're significantly different. There's quite a bit of learning curve difference between the TI-84 and the TI-Nspire. So I'd hate to have you spend a year or two learning how to use the TI-84, and then you get to college and everybody requires you to have the Nspire. Then you got to learn a whole new operating system. So if you have to go out and buy a calculator, and they will require you to have a graphing calculator, I'm quite sure.
Yeah.
Well, there's not all calculators are graphing calculators. Looks to me like that is exactly 18. We don't need a calculator for that. So what that says is that you must have done 18 tutoring sessions. If you made 198, 18 times 11 is 198. But notice how we came up with it. We couldn't figure that out without writing the equation out and substituting 198 for income. Then we could solve for x, but only after we did all that other stuff.
Okay.
And this again is y equal 11x is the equation that fits this asterisk. What does that asterisk say? I can't read that. Uneven. What?
It just says unsure how to do. So I just had a question on how to do one and then one other one.
Unsure how to do. That's what that says. Now I get it.
Yeah.
I couldn't make out that letter, and I couldn't figure out what it was. I guess I wouldn't be very good at it's that game where you got to figure out the words when you're missing letters.
Scrabble?
No, Wheel of Fortune. Wheel of Fortune, where they put up a bunch of letters and you have to figure out what the expression is.
Oh yeah.
And
right.
Once I knew that was an S, then it's unsure how to do for sure. But I kept thinking uneven and couldn't get past that, so I couldn't figure out what that meant. All right, let's go on. How much money would you make if you complete 25 tutoring sessions? Use your calculator on this.
275.
Good.
I already did the math.
Okay. All right, let's go to number 2. And notice that all of these are going to be linear. Linear meaning that it's going to be, you're going to be able to write it in the form of y equal mx plus b. It's a linear function. If you graph it, it'll be a straight line. That's what linear means. Okay?
Okay.
So, hold on a second. When I took this picture, it cut off the top row. I can't have that. I've got to take the picture again. All right.
Okay. One sec. I need to get a charger for the computer.
Okay. For the computer? Okay.
Yeah.
Okay. All right, we're going to want to write the equation in this form on all of these problems. Okay?
Okay.
What's y in this problem number 2? Is it how many days have gone by, or is it the height of the plant?
The height of the plant.
Good. What's x?
The days.
How many days have gone by? Okay. So, and what's the plant height when 0 days have gone by?
5 centimeters.
Okay. So give me the equation that fits this model. What's b going to be? What's the height of the plant when x is 0?
It's 5.
That's what b is. Now, what's m? How fast does the plant grow every day? In other words, what's its rate of change?
1.5.
So it's 1.5 times x, which is how many days go by. Okay?
Right.
Now, let's check that and see if that fits. Well, when the plant is 0 days old, what's its height?
5 centimeters.
That works. And it's growing at 1.5 centimeters per day. So after 1 day, how high would it be?
10 centimeters.
No. Fill in 1 for x.
5.
What's 1.5 plus 5?
6.5.
That's how high it would be after 1 day, right?
Yeah.
In other words, if it starts out at 5 and it grows 1.5 centimeters per day, what's it going to be after 2 days?
8 centimeters.
Perfect. That thing covers 1 day, covers 2 days. You can assume we've got the right equation. Now let's graph that. Where do I start?
At 5. So, yeah.
So that point's on the curve. What's the slope?
1.5 over 1.
Well, just 1.5, and I'm going to make up a slope that I'm going to call that 1.5. I haven't put any grid on it, so that's as believable as anything else. Okay? Now, question B. What's the reasonable domain and range of this situation? Remember what domain is. Domain is the allowable values of x. Can x be negative?
No.
Can x be 0?
Yes.
Can x be 10?
No.
Sure. You could let your plant grow for 10 days.
Yeah. Right.
Can x be 100?
Yeah.
Yeah, you could let it grow for 100 days. So the reasonable domain here is greater than 0. In other words, x needs to be greater or equal to 0. Negative values of x do not make much sense. That means we're going back in time. And I wish we could, but nobody's figured out how to do it yet. So this part of the curve, really, I shouldn't have drawn that. In other words, this curve only goes to there.
Okay.
And it does, at least according to all the information they've given us, it keeps going. In other words, if I were to wait 1,000 days, this is going to be a really high plant. Well, in practicality, that is not what happens. It's not linear. It reaches a point in height where it can't really grow any further after that. So there is an upper limit on the range.
Right.
From the way I've drawn it, what's the range? What does y have to be?
Five.
Got to be greater than or equal to 5. In other words, according to their explanation, the plant started at 5, and it only grows up every day. It doesn't grow down. So
Right.
it's never going to be less than 5. Okay, on day 2, it's going to be 6.5. On day 3, it's going to be 8, so forth and so on. So that covers the domain and the range, or in what they call here the reasonable domain and range. In other words, if I'm looking at just this function, then the domain is all real numbers and the range is all real numbers. But if I look at the function in the context of the problem, then the domain is not all real numbers. I can't have negative days. So the domain, x has to be a positive number or 0, and y has to be greater than or equal to 5. It can be greater than 5, but it's never getting less than 5. There's no point on this curve that I've drawn where the y value is less than 5. What's the height of the plant after 20 days?
$30 centimeters.
Hold on. That's the same question as saying, what is y when x equals 20? Do the math. What's that equal to when x is equal to 20? That's why you're going to need a calculator, always, when we do sessions.
Oh, 35 centimeters.
So we have a 35 centimeter high plant at the end of 20 days. Now, every situation they're giving us here is linear, okay? Meaning straight line. It's not quadratic. In other words, this plant is not growing like that. That would be exponential growth. That would be every single day the plant is growing more than the previous day. Whereas in our problem, the plant grows exactly 1.5 centimeters per day, linear. No matter whether you're on your second day or your 200th day, it's growing 1.5 centimeters per day.
Okay.
All right, number 3. Here they give us the function. And notice what they do. They don't give it to us in the standard format, mx plus b. They give it to us in this format, b plus mx. Well, that's the same thing, right? In other words,
Yeah.
the associative property holds. A plus b is always equal to b plus a. So the fact that they've given it to us backwards really doesn't matter. I can take that and say f of x, I'll put it back in the original format, which is 0.3x plus 20,000. Okay?
Okay.
That's her salary. Assuming, what's f of x mean?
It's the same thing as y.
What does it mean in this problem? What is f of x? Or y? You're right. I could have called it y also. But in the scope of this problem, what is it? Her salary.
Yeah.
If you were working at this job, you'd know exactly what it was. 100 times over. Okay?
Yeah.
because you would care about it a lot. F of X is your salary. This formula is being used to predict her total salary. So that's what F of X is her total salary. What's X?
0.3.
No, well, not yet. X is the total sales amount. In other words, always read the words. Achieving a total sales amount X.
Okay.
That's what tells you what X is. And you could go back and see that F of X is her total predicted salary. Okay. So let's say she doesn't sell anything. Her sales are 0. What is her salary?
$20,000.
Correct. Now, so that's her base salary, $20,000. Now, what commission does she earn? On a percentage basis. For every, let's say she sells $100 in sales, what will she earn on that $100? The coefficient in front of the X, 0.3, 30%.
So
let's say let's say her total sales were $100. Then what's her salary going to be? What's F of X going to be?
20,000.
First of all, let's take this part. What's 3/10 of 100?
30.
So 30 plus 20,000.
Yeah, 20,030.
Right. That's what her income would be if she only sold $100. Well, clearly this is a job where she better be selling more than $100, otherwise she's not going to make much money. Okay.
Right.
More likely she's selling things like cars, where every time she makes a sale it might be worth $10,000 or $20,000. Or if it's real estate, she might, well, nobody earns 30% on real estate. But cars, maybe. If you're selling luxury cars, you might get 30%, I doubt. But anyway, this is a very believable model for what she makes. So we've got her base salary, and her commission is merely the decimal that's in front. In other words, what is M? M is 0.3.
Right.
0.3 is 30%. Now, you didn't necessarily have to give it in. Yes, it did. It said, what commission percent does she earn? Well, 0.3 is 30%.
Okay.
All right, let's look at number 4.
Don't put music on.
Number 4 requires 2 variables. Unlike the first 3, notice that I was able to say F of X in all cases. And you could substitute Y. You might think the first 3 have 2 variables, and I guess in a way they do. But number 4 actually has more than 2 variables. It actually has 3 variables. Okay? Let's figure out what they are. The total income she's going to make. Let's call that Z. Okay?
All right.
And we're going to call X the number of cups of lemonade that she sells. And incidentally, when you're doing word problems, this is absolutely the most important step. This first step, where you define all of your variables. People hate word problems. And the reason they do is because they don't start them out right. Number of bars of candy. That's what Y is. Okay?
Okay.
So, what's total income? What is Z going to be? If you make $2 per cup of lemonade and $1.50 per bar of candy, well then what do you total? What's your equation going to be? Z is your total income. Going to be 2 times what?
So that's
2 times X. In other words, you make $2 for every cup of lemonade. X is the number of cups of lemonade. Plus what? How much do you make on a candy bar?
150.
For every one you sell. There's your equation. Okay? Now that's not a linear equation. A linear equation has 2 variables only, x and y, or x and f of x, but it doesn't have a z. So this is not linear. Doesn't matter, it's still an equation and we can still figure out all kinds of stuff.
Okay.
All right, let's see. He earns $425 selling lemonade and candy. So the first thing I can do is substitute 425 on the left side of that equation. In other words, Z is equal to 425, right?
Right.
Now, still don't know how many cups of lemonade he sold or how many bars of candy. Notice that there could be all kinds of combinations of X and Y that would equal 425. So there is an infinite number of solutions for that equation. There's not just one solution. You could have made $425 in any number of ways. Maybe she sold 100 cups of lemonade and 50 cups or 50 bars of candy. Maybe she sold 50 cups of lemonade and 125 bars of candy. In other words, you could come up with lots of different combinations that produce $425. I bet you never had a lemonade stand when you were a kid where you earned $425. That's a lemonade stand at Coors Field or something.
Yeah.
In other words, some of these aren't terribly reasonable. All right, so A is what we did. We wrote, now even though they're calling it a linear model, okay, I'm not going to argue with them. But the linear model is Z equals 2x plus 1.5y. Oh, I see why they do it. In other words, we know she made 425, so they've replaced that for Z, and now they have an equation that just has an x and a y in it. So, okay, so we now have a linear model. If you didn't know she made 425, you couldn't call this a linear model. But knowing she made exactly 425 allows us to write it in terms of 2 variables. That makes it linear. The sub-point that's not important at this point. However, now it says sketch that. Well, in order to sketch it, let's put it in terms of y equal mx plus b. Okay? Well, the first thing I'm going to do is take my 2x on the other side. So there's a plus 425 already over there, and now I got to divide everything by 1.5. In other words, I've taken this equation and solved for y. See how?
Yeah.
See how I get from here to there?
Yeah, you just
All I did was solve for y. Move the 2x over, the 425
then divide by 1.
there, and then I divide everything by 1.5. So I end up with y equals minus 2 divided by 1.5 x plus, what's 425 divided by 1.5 on your calculator?
283.3.
283.3. So there is our linear equation that's in y equal mx plus b format, which is very nice for graphing it. And that's what they
Right.
want us to do next, is to graph it. So let's graph that. I ran out of space here. I'm going to have to graph it down here. All right. Where do I start?
283.3.
What's the slope?
Down to right 1.5.
Yeah, and that actually is also 4/3. I could replace that with 4/3. So the slope is 4/3 and it's negative.
Okay.
So that's what the graph looks like. Okay. The x-axis is the number of cups of lemonade. The y-axis is the number of candy bars I sold.
Okay.
Notice that if I sold 0 cups of lemonade, I sold 283 candy bars. At $1.50 per bar, that would give me $425 in candy bars alone, 0 in lemonade sales. So notice that if I sold 0 bars of candy, that's this point here, then that's how many cups of lemonade I must have sold in order to earn $425, which is like 212 cups of lemonade. So on the x-axis, that's like 212. Okay? But you can see how this linear model fits everything, as long as we know she earned that amount. If we don't know how much she earns, then this linear model doesn't work. It only works if I know how much she earned and I can turn that equation into 2 variables only, not 3 variables.
Okay.
All right, let me see some other questions. Sketch it. What's an appropriate domain and range for the situation? So what's an appropriate domain for x? What are the allowable values for x? First of all, what's it got to be greater than? Remember what x is. It's the number of cups of lemonade she sold.
Right.
Can't be negative. Got to be greater than or equal to 0, right?
Yeah.
What's the maximum it can be? If she only made $425, that's this point right here. What's the x value of that point? Read it off the graph. What's that x value?
2
212.
or 12.
In other words, the number of cups of lemonade she must have sold have to be between 0 and 212. If she'd have sold 213 cups of lemonade, she'd have made $426 and counting, plus whatever she makes per candy bar. So it's impossible for her to have sold more than 212 cups of lemonade. She sold somewhere between 0 and 212 cups of lemonade. And that's the effective domain, and that's this range between that point and that point. In other words, y can never be negative, so I don't need this part of the line there. Remember what y is, it's the number of candy bars she sells. And y cannot be more than 283.3. So tell me what the range is. Y has to be greater than or equal to what, and less than or equal to what?
So it has to be greater.
The smallest amount of candy bars she can sell. None.
0.
Exactly. What's the largest amount of candy bars she could possibly sell?
Like any amount, or
283. This
283.
that number right there.
Right.
The y-intercept. And notice what that is. That is 0 candy bars. Excuse me, 0 cups of lemonade. If she sold 0 cups of lemonade and she made $425, then she must have sold 283 1/3 cups or candy bars. Now, I don't know why they would put a fraction in there. I suppose just to confuse you. In other words, obviously you can't sell 0.3 of a candy bar. And
Right.
there's no way they should have given you a problem that had a fraction. Should have been a round number. Okay? But they screw up sometimes when they do these things. And they shouldn't have, because all it does is confuse people. But I think you can see what I'm getting at here. It's impossible for her to have sold more than that many candy bars, because she would have made more than $425.
Right.
And it's impossible for her to have sold more than 212 cups of lemonade, because she would have automatically made more than $425. If she sold even 213 cups of lemonade, she would have made $426, $2 per cup. So the number of cups of lemonade has to be between 0 and 212. The number of candy bars has to be between 0 and 283. And that is the effective domain and range. And that's what they mean when they say effective. In other words, you can't just go what's the domain and range of the problem. Okay, this last question is the toughest one yet we've faced. Okay?
Okay.
Here's what we know. 400, and I'm going to put it back in the original format, is equal to 2x plus $1.50 times y, right? And you just have to know what x and y are. X is the number of cups of lemonade, y is the number of candy bars. Now there's one equation. We cannot solve one equation with 2 variables. You cannot do it. There are an infinite number of solutions. But now they're giving us this C here. And they're telling us that she sold 90 bars of candy. And they want to know how many cups of lemonade she must have sold. So what can I do? How can I figure out what x is when y is 90?
All right. So
Let's start. 425 equals 2x plus what?
150 or 1.5
Times, what's y?
y.
And what is y here?
90.
So multiply 1.5 times 90. You get 135.
Yeah.
Okay. Now notice I have one equation, one unknown I can definitely solve. for X, which is how many cups of lemonade she sold. So solve this equation for me. What's first step?
So you subtract 135 from 425.
So that gives you 290. That equals 2X. Now what?
And then divide by 2.
So she must have sold exactly 145 cups of lemonade and 90 bars of candy. Well, let's just check. Let's see. If she sold 145 cups of lemonade at $2 a cup, that's $290 there. And then she sold 90 bars of candy at $1.50 per bar. That's another $135. Add the two together. There you go. That's what she made. Now we know our answer is exactly right.
Okay.
And it never hurts to check. You want to do a ballpark check. In other words, if I went through this math and I came up with 1,000 for X, I know that's not right. That's outside of my domain. The previous question, we figured out that X had to be between 0 and 212. So if I didn't come up with 1,000, I'd have known I got a math error there. I got to go back and rework the problem.
Okay.
That's what I call doing a ballpark check, where you try to determine the reasonableness of your answer. In other words, you don't necessarily have to go through the exact mathematics to check your answer. You can just kind of make sure that everything's reasonable. And that usually is enough to let you know whether you got it right or not. I mean, a lot of times you can be off by like a factor of 10, and that will pop right out at you, where you'll see it instantly.
Okay.
And so that's the advantage of doing ballpark checks. All right. Give me an equation that states the first sentence. First of all, let me give you the general equation. The total weight. What's the total weight going to equal? If she has X books that weigh 2 pounds each and Y books that weigh 3 pounds is what they meant there. Each. So what's the total weight going to be? If you're carrying a backpack to school and you got smaller books that weigh 2 pounds each and you got bigger books that weigh 3 pounds each, what's the total weight going to be?
60 pounds.
No, well, not yet. Let's ignore that for a second. Let's get our full proper equation. The total weight is going to be 2 times X, because X is the number of your small books, plus 3 times Y. Y are your big books.
Right.
So this is the general equation for this model. Now they give us additional information. The total weight is 60. Okay, now I can fill in 60 for total weight. Now I have this, and this is linear. Linear, there's an X and a Y, and that's all there is. There's no Z. In other words, once they give us the total weight of the books, it becomes a linear problem. And the answer to A is that. 60 equals 2X plus 3Y. It's just that every time you write one of these equations, make sure you know exactly what X is and exactly what Y. In other words, X is the number of small books that only weigh 2 pounds each. Y is the number of big books that weigh 3 pounds each.
Okay.
Okay. Now, sketch a graph. Okay. Sometimes the easiest way to sketch a graph is to figure out the X and Y intercepts. Rather than manipulating this equation and putting it into Y equal mx plus b, Tell me what the x-intercept is and what the y-intercept is.
X-intercept is 2.
No.
Y-intercept is 3. Oh.
What is the y value when I'm on the x-intercept?
Oh, 0.
So plug in 0 for y and solve that for x.
30.
That's x-intercept. Now tell me what the y-intercept is.
20.
Yeah. Now, wasn't that a lot easier than putting it into y equal mx plus b format? I didn't need to know the slope.
Yeah.
I didn't need to know anything. The only thing I needed to know is my x and my y-intercept, and that's actually pretty easy to get when the numbers are right. In other words, if that was 2.2, wouldn't be so easy, because then I'd have to divide 60 by 2.2. But when they're using numbers like this, x and y intercepts are going to be whole numbers.
Okay.
What's the effective domain? In other words, once again, I've drawn the line to be the equation of that line, but in reality, the line has to go between these 2 points. Correct?
Yes.
In other
So
words, if I go to the left of that, that means I have an x that's negative. Well, I can't have an x that's negative. You can't have a negative number of books.
right.
And if I go below the x-axis, I'm saying that y is negative. Well, you can't have that either. So what is my effective domain? What does x have to be between?
It has to be between 0 and 20. Oh, wait, no, 30. 30.
Correct. That's the effective domain of x. What's the effective domain of y?
Between 0 and 20.
There you go. All right. If she has 10 3-pound books, how many 2-pound books does she have? So let's go back up into this equation. And it says if she has 10 3-pound books, so I can say 60 equals 2x, the number of 2-pound books, plus 3 times 10, 10 3-pound books. Now solve that. What do you get when you solve that equation for x?
So 10.
What's the first thing you do? What's the first step?
So
30. Now what do you do?
subtract 30 from 60.
Okay, so now I got 30 equals 2x. What's x?
Oh, oops. Wait.
Solve that for x.
15.
Now, let's check and see if that makes sense. She has 15 2-pound books. How much weight does she have in 2-pound books?
She has...
There's 15 2-pound books.
Yeah.
15 times 2.
30.
So she has 30 pounds of little books. And it already told us that she has 10 3-pound books. So that's another 30 pounds. That goes together, that's 60 pounds. That's what she's supposed to have. That's what she has. In other words, the original problem said she had 60 pounds in books.
Right.
Okay. All right. Let me go down one more. Just keep going here. So we run out of time. We only got about 5 minutes. And hold on.
It's a lot of books.
Yes. That's a thing of the past. I don't think anybody carries around 60 pounds worth of books anymore. In fact, most of my students do not have textbooks anymore. Do you?
No.
No, everything's online, right?
Yeah.
Yeah. That's the way it is nowadays. It didn't used to be like that. When I was in school, I probably did have 60 pounds of books that I had to cart everywhere. You know,
Yeah.
between a math class and a physics class and a chemistry class, you got some big books and lots of them. But not anymore. All right. Connor has $25,000 in his bank account, and every month he spends $1,500, and he does not add any money. Write a linear model that shows how much money he will have in the account after X months. So we're going to let Y be the amount in the account.
Okay.
And I can't tell you how important it is to spell these out as to what your variables mean. Very, very important. What's that equal?
X is the how much he spends.
Look at the last line. How much money will be in the account after X months? So what is X?
How many months?
Yeah, number of months that pass. Okay. So we can look at this, and the easiest way to look at this is we know he starts out with 25,000, right?
Right.
And we know it's going to get nothing but less. I'm going to subtract 1,500 per month. So what's the rest of this equation? What should it look like?
The
1,500 per month. Now,
right.
tell me how much he would have in the account after 0 months.
He would still have the 25,000.
Works for that. How much would he have after 1 month?
23,500.
Works for that. How much would he have after 2 months?
22,000.
So this is the correct model. It works for 0, 1, and 2 months. Once you prove that to yourself, then you've found the correct model. How much will he have after 8 months? That much right there.
Okay. So
13,000.
Okay.
How much? You see how I got that? 13,000. Yeah. Okay. How much will he have after 100 months?
So only 10. Wait, no. 15, 1, 6, 1. Yeah, 10.
After 100 months, he's losing $1,500 per month. Means he's going to lose $150,000. Well, he only started with $25,000. Can the bank account go negative?
Yes.
No, it can't.
Yeah, I guess you're right.
Not really. I mean, there are bank accounts that will let you go negative, but in reality, no. In other words, when he runs out of his $25,000, the bank account is at zero, and he can't take any more money out. He can't spend $1,500 anymore. It's all gone.
All
So
right.
at the end of 100 months, he's well past zero. In fact, at the end of 10 months, he's down to 10,000. At the end of 20 months, he would be below zero. So the effective domain on X is somewhere between 0 and probably 18 without doing the math. I don't know. But you can see that it's not going to take that long for him to completely drain that bank account at $1,500 a month.
All right.
Okay? Let's stop at 6, at number 6 here, and I will let you go. And let's see, I have a scheduled next week for 2 sessions, Tuesday and Thursday at the same times. Just double checking that. Does that still work for you, Demetrius?
Yeah.
I will talk to you Tuesday at 4 next week.
Okay.
All right?
All right.
Bye-bye.
Cool.